Alright. Alright, I'm just gonna start here. So, yeah, we've been fiddling around with these generic iterators. And I actually made, well, I actually want to do a couple of improvements on this. It's not going to be a huge thing, like a huge rewrite or anything. I want to add some more functions here, which is going to be like generic for all iterators basically. And then I also want to extend this from function so that we will work on more things than just custom iterators. And also, so let's start here actually. So, well, what I was gonna say is if, so I want to add two things here. So one is if the iterator, if the type of iterator is, or I guess this could be source. Let's call it source instead. If the type of source is a generic iterator, then just return it. So basically, yeah, if we all, because the whole purpose of this function is to turn something into a generic iterator, but if it's already a generic iterator, then we should just return it. And I did play around with the idea that we could make it a sort of compiler error to sort of catch the places where you're invalidly, or it's not invalid, but it's like, yeah, inefficiently calling from. However, it's not actually a problem, you know, because it's like all in comp time. This just returns a type, and also it would prevent, or it would make other stuff harder, like if you want to have other generic functions that take a source of any type and then call from on that to make sure that it's a generic iterator. And then if that becomes like an error, if you pass in a generic iterator, then you would have to like deal with it in that function, which is just feels bad. So I'm just gonna say if it's a generic iterator, then we just return it without doing anything. And two, I do want to add a case for if type of source is a slice, and this could, you know, in extension become any sort of iterable type, but if it's a slice, we already have an iterator for it, so then we can just call slice iterator and return the result. So we already have the allocator, so we can just, you know, return the slice iterator on the slice itself, and it should work really well. So those are the two things I want to add here. And then down at the generic iterator implementation, I also want to add a map and a filter function that will in turn call map iterator and filter iterator, which will be, I think, a better pattern than to wrap an iterator in a map iterator. Instead, you could have any generic iterator and you call .map on it to actually map the thing directly instead of wrapping it. So I think that's a little bit better pattern, and also for filter as well. So let's start with the first case here. So we want to check if iterator implementation is a generic iterator. So the way we want to do that is we want to basically grab the iterator element out of the iterator. Now this would be just in the case that it's actually an iterator. However, if it's not an iterator, we actually want to have the case for a slice later. But let's do this first. So that means we need the iterator element up here, and then we probably want to validate it, but well, we're sort of validating it by checking if iterator implementation or I guess we can call this source. If the source type is equal to generic iterator of element t, then we can just return the source. So yeah, because it's the same thing. So we don't really need to do anything. We can just return the source type directly. Or I mean, we can just return the source, I guess, the source value. That's right. So that's one case here. And I'll just make sure that we don't get any sort of weird errors from this. So that case is done. Now the other case is like if the source is a slice, then we wanna turn that slice into a slice iterator. However, we need to do that up here, because here we sort of already, it's going to be an error here if the type is not an iterator. So what we want to do is we want to say here we want to do a switch on type info source, and we want to check if it's a pointer, and if the pointer is, so if the pointer dot size is equal to slice. Oops. So in this case, we just want to return slice iterator of source, because now source is a slice, and slice iterator source of limit pass allocator will just return a slice iterator of that. So we're basically turning this type into an iterator. All right. Now, if it's not a pointer thing, we need to actually validate that it's an iterator interface. All right, and then we can remove this validation here. So yeah. So now we can call from not only on iterator, like custom iterator types. We can call it on generic iterators. It will just return the source directly. We can call it on slices as well, which will turn it into a slice iterator. So that's very nice, because now we don't have to import a slice iterator and call that. We just call from on the slice to get the slice iterator directly, which is basically, I mean, it's the same thing really. It's just that you call from instead of slice iterator, but hey, it's I think it's, yeah, it's more like streamlined, I would say. Now let's update the documentation here. So converts an iterator type into generic iterator. So I would say, I mean, I would like to say iterable here. Iterable. Either a slice or a struct with Alright, so this looks like this now. So either you pass in a slice or a struct with next and reset. And here's an example. Here's a custom iterator example, and we can also do a slice example. So this would basically be my slice is a slice of F32s, 1, 2.5, 3.75, or whatever. And then my slice iterator is going to be from allocator my slice. Alright, and that's your iterator. So that's all you have to do there. And I guess we can say that now we get a generic iterator of F32s. Okay. Just see how it looks. So that's the example here. We have a slice, we put that in from, and we get a generic iterator over the slice. And here is custom iterator where we make our own iterator over the slice. And this also works. All right. It's nice to when you've made sort of this when you've made like a more, I guess, advanced, or I mean more, I guess, convoluted type or thing, machinery here, abstraction, I don't know what to call it. It's nice to add some like documentation to the functions that might be like, okay, what's this from? Like, what does it do? Like, you put in source, anytype, and an allocator. I mean, you can see that you get a generic iterator, but it's nice to have examples to know what you're dealing with. And you know, if I'm gonna leave here and get back here in a couple of weeks or something like that, if something comes up and I have to like leave and come back, I will really appreciate that this is like commented in this way to I can exactly see. And I really like having examples, because that really helps, at least me. If I don't see examples, or if I see an example, I'm just immediately gonna get it, basically. If I don't see an example, you have to read and just interpret the other information, which takes longer to see. Without examples, it's just like I need examples to just see how to do stuff. Well, that's not entirely true. I don't need examples, but it just speeds things up a lot. All right, so let's go down here now. And what I want to do here is I want to add a couple of functions. So these are sort of the main functions here. This is like the main implementation here, and of course the initialize, but that's like internal. And then these are sort of the extensions, you could say, to the type here. And I'm gonna add two more functions here. So I'm gonna add map, which is basically gonna take let's see, we are gonna do, let's start here. So we need a map function. So this will basically be I guess pointer to a const, or is it comp time? No, I think it's comp time map function. Let's just make it comp time function, which takes a element of t and returns some sort of element of u. I think this should be like any type, because we can infer the return type from that, unless we want to sort of spell it out here, because then the LSP will also get it. I think I'm gonna go with any type, since it's easier to type it out. It is nice to get, you know, the actual type out, but yeah. Let's see, so how do you do this? You take type info, so this is gonna be type info of map function. I mean, I'm surprised there's no like just return value, like just getting return type. No, let's make a function, and this would be the function, which is this, and then this is going to return a type, and we're just going to return. Well, actually, this should be like a comp time type, and then we return. Well, I guess it doesn't have to be. Let's just make comp time any type, and then we'll return type info type of f, and this is a function, and return type. And I think it works like this, like if the return, because this is nullable or it's optional. So yeah, okay, it even says here in the to do change language specific is not optional, because the thing is that if it's not null, if it's null, then I think it just means it's void. which is a type. So it's surprising that this is actually optional, but what you do is just to say or else void. So there you go. Now you got the return type there. All right, so let's say return type of this function. So there we go. Or actually, no, this the map will return a generic iterator, but the element is going to be the return type of the thing. Okay. Right, so what we'll do is we'll basically just call map iterator. Oh, we need allocator as well. So sure, let's put allocator here. Allocator, and then we also need the iterator, which is gonna be a generic iterator. So we can just return self here. Actually, we'll return. No, we could just. This could be. This doesn't need to be mutable, so we can just do this. This will return a new iterator, but it will sort of map over an existing iterator. So I guess, yeah, one change in having the data like a pointer like this would be that each iterator lives like in one place. So if you call map on one iterator, then if that iterator is then being used somewhere else, then the map iterator will also be like affected by that. So but I guess that's up to the user to make sure that, you know, you're using it correctly here, or that you know what's going on. So map iterator and allocator, and then it is our like iterator that we want to map on, and then we need a map function. So this is just going to be the map function here, and then we get our generic iterator back there. So that is basically all we need to do, because the map iterator is already implemented over here, and it's basically pretty simple. It's just you take a function, you take two types, well, input type, output type, you take a generic iterator. Next function is just going to call next on inner. We call map on the result. If inner next doesn't return a result, we return null. So, and reset just calls reset on the inner iterator. So yeah, very, very simple here. But this allows us, now with that we have map here, this allows us to actually create what is it, to not have to wrap the generic iterator with map iterator. Instead we call this function map to get a map iterator instead. So it's basically inverting the order of operations, you could say. Not like logically when the according to the iterators, but the way the code is sort of structured. So the way you kind of reading the code is inverted. And I think this is a more nicely thing, because now you can say, okay, I want to from this slice, and then I want to map to this, and then I want to filter to this. So instead of saying filter on this mapped iterator with this slice iterator. So yeah, I think that's a bit better there. All right, let's put all these there. So that should be basically the same thing with filter. We just provide a filter function now instead, and we call filter iterator here. We're actually not doing any sort of what is it, validation here. We do get automatic sort of validation here. It's just that the error message might be a bit weird. I mean, it does say that filter function doesn't return bool. Let's say it returns something else, then you will get this error message here. So you will be able to trace it as well, because the stack trace will be shown in the log. Okay, but now we have this map and filter, so let's put them to use. So let's go to where we are actually calling these things. So here, for example, we're calling map iterator on these responses. Now, instead of doing that, we want to call responses.map. Oops. Wait, why do we not get the thing? Oh, equals. Sorry. And I need to spell it correctly. Okay, so map. So now we can, now we can use, now we can do map, and we need to put in an allocator, fine, and we need a function, which is this one here. Right. So, oops. So now we have basically the same thing here, except we don't need to initialize it either, because we are using. Well, actually, we need to use the frame allocator here. Frame allocator. So we did it this last time. I made a frame allocator, which the purpose is things that's only gonna live in one frame. It's not gonna live throughout multiple frames. So we have a special allocator for that, which is an arena allocator, and it gets reset every frame. So you don't have to deinitialize things allocated with this allocator. And the purpose is basically to allocate a bunch of small things that's required each frame, but then we retain the capacity so that you don't have to like do a bunch of syscalls each frame. So that's nice. All right. Now this would be frame allocator.allocator. There we go. All right, and then we don't have to deinitialize it as well. So this is a bit nicer, because now you see, okay, we start with responses and then we map it with this map function. It would be a lot nicer if we could just say map and then response.label, but we're in SIG world, and this is how this is what we need to live with. We could, you could make this function somewhere else. You could also you could like you could even do this. You could do like public function get label, and self would be response, and this would return wait, and then we return self label. So we could make this function, and then we could call. Oops. Okay, so instead of making the struct, we could do dialog option response.getLabel. So this would be the function that we put in, because the input is going to be a response, the output is going to be the thing. So this should actually probably work here. Yeah. So that's actually a lot nicer, I think. Just define the function on the type itself, and I just pass it into a map. And then the only thing we need to actually do is put in the allocator as well. All right. So yeah, a lot nicer. That's a lot less noise in here, And then we actually you see what we're doing as well. We're getting the label out. Now you could potentially, could you make a generic function for that? Like get field. Is that a thing? Field. I mean, I know there's like the at field, but what I want to do is basically make a function. Wait, can you do that? Let's say you have a function. I can't make a function here, but let's say you have a function here. So let's say this is like field getter, and you would have a type of the struct that you want to get, and then you would have field enum of this type. So this would be the field tag. Alright, and then we get a function back, so that would that be a type or a function? No, it's a function, right? So this would be a function that takes t and returns the field type t, and the field is field tag, right? And then now we're getting making more like anti-zig stuff here with the sort of functional stuff here, calling a function, returning another function. But I'm not sure if we can do it, but let's try. So this would return a struct, and we need a function here, which is gonna be the getter, and we're gonna get the struct here, that's t, and then we're gonna return this field type t field tag, and then we'll simply return at field of s, and then we need the tag name of field tag, right? Because that's comp time. All right, and then we do this, right? Is that even possible? I mean, it's possible to, you know, call a function to create a type like a struct. So why wouldn't we be able to call a function that returns a new function here? So now we could, instead of defining this get label or defining these functions, we could say I want a field getter of this type, and the field is label, and this is actually comp time, you know. Dot label is an actual sort of enum that you can use, right? All right. Okay, but let's see, map iterator. So let's check where we're using it. So we're using it here. So let's do the same thing here. Now we have options instead. So let's do options.map, and this is the mapper. However, what that is doing, we're calling like option.option.label. Right, that's the info. So we could now, this is a bit more involved, so we have to basically, let's just make a function here. It's called getLabel. So this will just return self self.label. But then if we don't have a label, I'm just gonna return empty, I guess. Or this could return no, but we don't want that. We want the thing. I guess we could put a default value here, default value, and we'll put that there if we get, so that could be a thing, yeah. So now instead of doing this, we could say dialog option info.get label. Oh shit, but then we don't have default value. Oh man. Yeah, I mean, I know that technically we could also make now a functional thing that we like supply the default value with a function, and then we create another function that calls this function with that. But I'm not gonna do it. I'm just gonna say this. That's fine. All right, so there we go. Right, so now we have the options. It's a generic iterator. We can call map on that to make a new iterator, or well, it's a mapped iterator. It's not a new iterator. Well, it's an iterator that also maps the value, but it still uses the underlying iterator as a source. So if you're iterating through this now, the source, it will also affect this map iterator. So you have to be aware of that, but yeah. Anyway, so yeah. Now let's see if we have anywhere else where we call this function here. Here. Okay, so let's change this as well. This would be shown options.numeric. And yeah, this is used several times, I believe. Or did it? Yeah, you can see here is also like a place where we do the same thing basically. Actually in 3 places, no? Okay, but we need a function for this, so oh yeah, maybe this one is like unused now. Okay, let's just delete this one. Yeah. I think let's just double check that. Yeah, it's unused. And this one is also this is also unused. Yeah. Because we're using our new shiny generic iterators that can be composed and stuff. All right, so let's see. This one shouldn't be used either, so let's just remove this. Right, and this one is also not used. Do that. Okay. Now what the hell was I doing here? So was it this one? No. Get responses. No. Wait, where was it? No, I removed it. So yeah, shown options dot map. There we go. Here it was. So yeah. So this function I wanna move to a new function. I think maybe we will do the same thing here. Actually, let's just copy this entire thing. We'll make a new function here, which is like toResponse. Right. That's it. And then instead of doing all this, we can say info to response. There we go. And this even fits like this. Okay. Cool. And I want to check also the other places where we're doing this. So where would that be? Like option info, no, info option. Where was that? Option.option. God damn it. Here, to response. Well, let's search for this. Oops. No. Where was it? Okay, wasn't it in here? Maybe in here. Okay, I don't know what happened there. Oh yeah, it's not in here. Of course, it should be in here. But I'm not sure where it went. I'm pretty sure I saw other places where we did the same thing, basically. Where did it go? No, this there. Yeah. Okay, I don't know. Okay. Anyway, we don't have compiler, so let's actually. Well, do we use filter iterator anywhere? No, we don't. So, well, do we use slice iterator? We do in UI. Okay. So now here we can say from instead. So. Yeah, from it takes it so the idea is it would take any iterable type and turn it into a generic iterator. If it detects if it's a slice, and then it returns a slice iterator over it. So so that's fine. Okay, what's this now? From text allocator first, right? Where's the actual, yeah, allocator first, and then labels, which is a slice. Now what's the issue? Oh, okay, so the idea is to here we're checking if it's a pointer, the size is sliced, then we return slice iterator. So we don't actually go down and validate at that point. We don't wanna say it's a iterator interface, so we don't need. So it's basically first we check is it a slice. Okay, then we just return slice iterator and we're done. Otherwise, we validate iterator interface because we are assuming it's an iterator, like a custom iterator with a next function and filter and reset function. But am I doing something wrong here? So this should be correct. We get the pointer, we check the slice. This is clearly a slice. Oh, we're calling iterator element here, which, oh, okay. So this is not iterator element. Okay, so this is more, we need a more generic element function. I guess any element, iterable. Now, yeah, so we want to switch on this. Otherwise, we're just gonna say iterator element. Okay. Let's do it. Actually, now, but what if it's else here? Then we wanna throw a compiler error, I guess. Invalid iterable. Okay, there we go. Okay, now we got rid of the error. Alright, so I guess this could be more generic as well. We get the T here. Guess we could have this up here now. Alright. Okay, now that should work. Now let's try it. I wish I could use the new compiler and compare the compile time, but it doesn't support vectors yet, from what I understand. So, or there's something that it doesn't support that I'm using, which I'm on SIG 0.14.1. Let's see, iterator expected struct. Oh. Well, why does it still go in here now? So it's checking for that iterator element called from here, -6. Oh, iterable. There we go. All right. There we go. Well, it seems to work. So we'll check the. Oops. This guy. All right, cool. So it seems to work. No leaks and great. All right, so that's really nice because yeah, I really like that improvement we did to these iterators. So yeah, this is a lot better than what we had before. All right. Okay. I'm just trying to figure out the next step here. Or we could just go through and fix up the clean up this these functions that uses these things. Well, here for example, we're actually using getShownInfos instead of this. This returns a slice instead of iterator, so we could actually, let's say we use the iterator version instead. We don't call allocator free on that. Here we have to pass the frame allocator instead now. So that would be frame allocator. And the options, well, that's keys. Yeah, that's keys. Yeah. And then we have handle list input. So did I make a version of this? It doesn't seem to be that way. So here's a place where we actually need to do some stuff. We want to adapt this to use iterator instead, I guess. Well, the only thing it needs really is the length here, so we can just call count. Okay, that will iterate through once and return the count, and then reset, I think. Yeah. And then the only thing here, and then here, this basically access the element. We also have a function for that. So element current option dot option. All right. And we need to make this mutable. There we go. So that's interesting because, yeah, I was thinking like we don't actually pass the list somewhere. We just pass the number of items, and then we, yeah, because we don't need to know the sort of details. We're just choosing from a list of things, so we don't need to know any of the details. We just need to know how many items is there. If one is accepted, we get the index of that. Yeah, makes sense. All right, so we don't actually have to change like the implementation of this function, which is nice. All right. And so yeah, so now we're using iterator here instead. Which is it from this standpoint, it's like, how much do we really gain? I think we gained, I guess, a couple of loops going through these options, I think. Yeah, there's one. Yeah, we gained stuff. So there's a reason to it. What else do we do? Because what we can do is we can go here and we can now see if we can get rid of the other one. Let's see if we can get rid of this one. It's still gonna used. Wait. Oh, it is gonna used here. Okay. No, that's it. That's not it. No, it's not getting used. Okay, so this one we can remove. Oops. And we can rename this now. There we go. What about this one? Get infos. This isn't even called. This isn't even used. Remove that. Oh, it didn't fix these. There we go. All right. What else can we do? Like anything that doesn't return anything that returns basically a slice and not an iterator here. I'm gonna check to see if we can turn that into an iterator instead. Okay, cool. So yeah, this is done. That's fine. Yeah. Also, now this is kind of possible to do with the composition instead, but I'm not sure if it's gonna be like worth it. But we could do this with composition if we have like a map that can have context, which should be possible now actually. So let's see if we can do that actually now that we're rolling with these iterators. Okay, let's do it here. Let's do like map iterator with context. Well, let's do this one first. So we need actual implementation here. Map context iterator. So we need a thing here. We also need the context type. So context goes first. Sure. Do we need? No, that's all the types and stuff. We're putting the context here. So I think we're storing. Do we store like a pointer to the context, or do we just? Yeah, because we can't change the interface of next, so we can't like put. No, we have to put context here, and it's probably gonna need to be a pointer. And then the mapper is gonna take self of context here. All right. Now this function is going to be map context iterator, allocator, iterator, mapper, and we also provide the context. Let's put it here maybe. Let's just infer the type here as well. This is just type of context. Actually, it would be the inner child. This needs to be a pointer. No, pointer and child. Alright. And then we do a map context iterator with context over here. And mapper is fine. Yeah, and then context is context. All right. Then we can go over here. We can grab this. And we can now say map with context. And we have some sort of context there, add a type, and we call map context iterator. There. All right. So now we have that. So what I'm gonna do is I'm gonna try and we're gonna see if this is actually, you know, a good thing, but readable or whatever. But I'm gonna try and just make this into a composed version now, because this should be possible now. So where is this used? It's used over here. So we'll start with slice iterator on keys. So this is going to be a iterator from keys, right? And then we're going to call map. No, we're going to call map with context. So the first part is this. That's like the slice iterator. The next part is this here. This is the map part. So we're mapping the key to an option info. So basically we need to define a function for that as well. We're gonna define the function here. So this one is states key option info. So we can basically just pass this function basically. Yeah. We're just gonna pass this function here. Right? So get option info by ID. Okay, and then we filter and we say, well, the filter function is going to be is, this is going to be, where's this info here? The filter function is going to be is shown. So So this is going to be dialog option info is shown. Okay. And then we're done. Yeah. So, I mean, you could argue which is more readable. This, you start with keys, you map keys into the get option infos or in option infos, and then you filter on if they are shown. This is more like declarative. You're clearly defining what is happening. However, you're not seeing the full picture in terms of actual, you know, imperative programming on what is actually happening here. We don't see that. However, if you know the system, if you intricately know the iteration system, you know what's happening. So I think that's like, you can argue like pros and cons on this and readability and stuff. This is basically taking what we actually need to know in order to know sort of the algorithm, you could say, or this is like the important parts of what's actually happening, like describing more in a manner of bullet points, you could say, of what's happening, rather than showing the entire algorithm by itself. So, oh, also we need to provide the context here, so we need to put self here as well. But this compared to, like, we start with keys, we map to option infos, and we filter on if they are shown. So that's what's happening. And then contrast this with this, where we have to deal with, okay, we're checking index, this is more than the length of the slice, then we return null, and we're done. Otherwise we grab the key out from the list, we increase index by 1 because we have to do that, and then we do the mapping here into this info type. Then we filter here with if. You could argue that this part is more, it would be cool if this was the actual, like, if this is what we wanna, if this is what we could type in, but it's just, yeah, I don't know. And then we return next. So I don't know, I think this is a pretty good substitution for that entire thing. And now we can just delete this, oops, and we don't need this entire thing here. It's pretty cool that you could substitute that entire thing with this 3-line short thing as well. Even though, you know, for me, I'm the one programming in this. I'm the only programming here. I'm the one that made the system, so I know how it works. One downside though is that if I leave and come back, I'm gonna have to relearn a little bit here. But if you're used to patterns like this, it's not gonna be a huge problem, you know. And yeah, we need an allocator here as well. All right. So com time value, what? No, self allocator. Oh, the context is like this. Okay. Context first, and then the function. All right. There we go. And then here, iterator, generic iterator found, iterator pool. Okay, yeah. So I think this is the issue here. We're not. Okay, this is wrong. So this shouldn't be the return type of that. This should just be. I mean, we should just return this actually. Yeah, we should just return the same iterator as we had before. Okay. What's this? Expect stays found this. Right. So, well, this is interesting. This expects a constant. Okay. Okay, I mean, if we're mapping, we shouldn't allow side effects to happen, I guess. So it does make sense that we wouldn't actually need this to be mutable here. Actually, we could still have a pointer, but when we're calling this function, we can dereference it, I guess. And the reason for why I want it to be a pointer is I don't want to copy the entire structure. If the context is like huge, I don't want to copy it. Yeah, this makes sense. It's just gonna live in one frame anyway. So, all right. Okay, so now, yeah, now we're done with the compiler errors. Let's see if it actually runs. Yeah. Okay. Well, I haven't tested the responses. Let's just remove the save file. So we reset the game basically. Now we get this, and there's the responses. Okay, cool. All right, so it does seem to work still. Nice. Okay. What else are we doing in here that we can change using iterators now instead? Right, so this one, get shown infos, is now fully modularized with these like composable iterators here. Nice. Okay, so that's it here. And we could extend this. We could go to quest system and also like upgrade, or I mean change the way we're dealing with these as well. Quests. How do we do this? There's not, so I think there's less stuff in here that we need to change. Here, for example, here, get active quests. I mean, what are we doing here? So we're making a tiny list and we're checking for some state here. If it's accepted and not completed, we append it into the list and we're returning the list. What could we do here? So which one are we? So we're looking at this part here, the value. So technically you could change this to be like iterator from values then we want to filter on these things. So I'm basically gonna check like is active quest. We could yeah, we could just go states here and add a function here called is active self quest state is accepted and not completed. Right, so we filter on quest state is active. Alright. And then we need to map to an info. So do we have a function for that? I don't think so. Alright, then we need a context. So we need, or do we need a context actually? Well, let's just say to info and this is gonna be state. So it's a bit the same thing here. Get quest by ID. So this one, yeah, it's not even using this. Let's just remove that dependency there. All right. Here we actually don't even need this. All right, because now we can just call that function without having the state. Wait, we need a key though. What is the key? It's the state. Oh, it's keys. Okay. I mean, we could do map first. We could do map with context. We could do basically the same thing. We have map with context. The context itself. State to info. Self is quest states, except we don't need to be that states. And then we need a key. Right. So we're gonna iterate through keys instead. Quest worthy? No. It's just gonna be states dot get key. All right. And this whole thing is replaced by this. Oh, you need a point. I guess we'll do the point instead. Expected type. Yeah. So now we change the return type here to generic iterator of quest info. There we go. Active quests. Right. So now this is a generic iterator instead. We don't need to free it. However, we do need to get the frame allocator now. Let's put the frame allocator here. There we go. And now get active quest. So wait, do you even need to be? You don't need to be pointer actually, right? No. Okay, it doesn't really matter. Yeah, so now instead of doing this, we iterate through it. All right. That needs to be 4. There we go. Okay. Okay, we got a whole bunch of things happening here. Interesting. Quest state. Oh. Let's see. Where did it go? Here. So we're using keys. We're turning it into info. And then, oh, quest state. So we should put it on info and not state. I mean, I guess we could have it here as well, but we're not using it, so. Oops. This would be info. Self.state. Alright. Right, so we're using it here as well. So let's do var, we don't need to free it, let's do frame allocator. Oh, we don't have L here. And there we go. Now, what's happening here? We're doing quest labels. So here we can also do a mapper instead. So we're basically going through active quests, making quest labels here. So quest labels could just be active quests.map. And then this could be actually I wonder if you could put the like when you put the function here, if you could if it automatically knows which one it is. Let's say could you just do dot is active here? I'm guessing no. It would be cool if you could do that. Because here we need to do quest info dot and then map to label or get label or something like that. I need to define it here. Get label. Right, so now we don't need to do any of this. Now I have the quest labels, and we can call this version now instead to which accepts a label iterator instead of a label slice. So that just works there. Now I'm curious, does this work? Well, I guess we'll see. Let's see. So here we have active quests again. Frame allocator. Active quests. Don't need to free it. All right. Now we can just call count. Right. This is the same pattern as before. What about here? Open quest. Current selected quest. I mean, fine. This is an index, yeah. Then active quest, open quest. yeah, this would be element instead. Also element, so this we should reset after this. This actually advances the iterator to the index, but it doesn't reset the iterator, so we have to be careful of that. This could be like, okay, this is a common enough pattern now that I'm gonna actually implement a function here, which is like because I don't want count. I don't want it to count the entire thing. I just want to know if it has any items. So I'm just gonna call it has money. So if next is not equal to null, then we have any, we reset, return any. So it's a bit more involved than just checking length, you know, but whatever. Pros and cons. So here we can basically, we can say has any. If it doesn't have any, then we return. I guess is empty is maybe a better thing. Is empty. Return if it has no items. If it's so any, so is, so empty, or result, I guess we can call it. Result equals if this is equal to null. Right. So if it is empty, return. All right. Quest labels, that is just passed in. Alright, I guess it's copied in there. We don't need to do that. Okay, cool. Wait. Const 8 uniform. Wait. Oh, I see. I need to do this. I guess. There we go. Okay, no more errors here. Right, so this is probably stemming from the fact that we're trying to just call dot, like whatever it's called, like a implicit declaration access here, like is active. So we can actually do this. We have to say quest info dot is active. But it would be cool if you could do that. But I guess how would it know which type to pick from? Okay, so that's good. Now we have one more thing. Access union field pointer was struct is active. Interesting. So we have a map context that is. Okay, yeah. So we have map context where we don't say. Okay. Well, that's an issue. So let's make this a pointer, I guess. It's not really that big a deal. There we go. So we still saw that. No more compile errors. Let's reset the save again. blue. We want gems. There we go. Yeah, and this all works as it did before. Yeah. Okay, cool. I think that's it here, maybe, for quests. Yeah. Yeah, and menu also uses that. Now it would be interesting here. Do we actually use this now? We don't. So we could technically remove this function and then just only allow iterators. Let's wait a bit to make the compiler make the changes trickle down. There we go. Okay, will this change to other places now, or will I get a whole bunch of errors? No, I get errors. All right. All right. Cool. So we got that working. Now this would be sort of well. I'm gonna have to go now, but yeah, it's really nice. We got the iterators actually. Like, I think we really made the iterators a lot better now. So they are much easier to work with. We ironed out a whole bunch of issues, and yeah, really easy to define them now and use them. And yeah, I have cooked up a little bit of ideas for how to expand on the content of the game. So I have figured out basically the big sort of, you could say, equipment that you could have in the game, and that you can use to like solve puzzles and stuff, which is going to be sort of like the, not a gimmick maybe, but more like a very important item that you get that you can like use. So I'm gonna try. I mean, this is gonna be just it's just at like a concept stage right now, but I'm gonna make some graphics for that and do some add some implementation for that, and so that will be sort of the start of the puzzle elements in the game. So yeah, that's pretty exciting, and but yeah, that's gonna be it for this time. So hope you have had a good time watching here. So yeah, that's gonna be it. Have a nice day, and I'll see you later.